So today we're going to be analyzing residual plots a little bit more. In your notes, you have a list of how to create a residual plot on your calculator. I'm going to show you how to do that in the video in case those steps are a little bit confusing. So let's take a look at our first example. A study compared the speed in miles per hour and the average fuel economy in miles per gallon for cars. The results are shown in the table. Use your calculator to make a residual plot of the data. Is the data best displayed by a linear function? Explain. All right, so yesterday we learned that if there's a pattern in the residual plot, the linear model is not the best fit. If there is not a pattern, the linear model is appropriate because you want the points scattered above and below. Your calculator will actually create a residual plot for you. So in order to have the calculator do that for you, we're going to go to second stat plot. And in our stat plot 1, we're going to press enter and we're going to change Y list to resid by choosing second list, choice 7, and enter. So now if we go back to our second stat plot, we see L1 and resid. So that's going to create a residual plot for us. So now we need to also make sure that we have our diagnostic on. So if your diagnostic is not on, make sure you turn that on. And we're going to enter in our values for our table. So we're going to go to stat and edit. And as you can see, I've already got all those points entered in. So you can pause the video here, take a second, and enter those all in. Okay, so now that you've got those all entered, we're going to also calculate our residual. Go over to L3. Oh, before we can calculate our residual, I just remembered we actually have to calculate the line of best fit, or it won't calculate the residuals for us. So before we do that, we're going to go to Stat and Calc and 4 for Lin Reg and enter all the way through. So now it's calculated our line of our best fit, and now we can run our residual. So now we can go back to Stat. We can go over to Edit, up to L3, second list, and choose choice 7 and enter. And now we have our residuals. And notice we have the same number of residuals as points that we entered before. So if you wind up getting a different number of residuals, it's because you didn't calculate your line of best fit. So it's giving you residuals from another line that you did earlier in the day or yesterday when you used your calculator. So now that we've got that all entered, we can choose Zoom 9. And now, instead of seeing our whole coordinate plane with a line of best fit, we see a residual plot. So I'm just going to sketch that so we can show it here. So if this was my residual plot, I can show the points as looking like they do in that graph. Kind of goes something like that. So it's clear that there is a pattern here. So if you remember again from what I explained earlier and what we learned yesterday, the data is not best displayed by a linear function because there is a pattern in the residual. Okay, so hopefully you were able to fill that all in the top part. I had to go down a little bit further. So now for the next part, it says, if not, determine what type of function should be used and use your calculator to find the line of best fit. So now I want to get out of this residual plot. I'm going to go back to second stat plot. I'm going to turn that residual off and change it back to L2. So back to second and list, change it back to L2, choice 2, and enter. If I go back to second stat plot, now I see L1 and L2. I'm going to go to my list or my edit and get rid of my residuals, clear and enter. And now I want to just make a regular scatter plot of this to see if I see what might be the better fit for this. So now if I go to zoom and 9 again, now I see what the actual data would look like in a regular scatter plot. And from that, it's really clear that this would probably be best represented by a quadratic function because there is a definite U shape there. All right, so remember when we're doing that, you cannot tell by the residual plot if it would be quadratic or exponential. It's important that you create the actual scatter plot and then decide from that data whether an exponential function or a quadratic function would be best. So here I'm going to say quadratic. So now we're going to do quad reg to find the equation of best fit. So we're going to go to stat. We're going to go over to calc and down to choice 5, which is quad reg, and enter all the way through. So now my line of best fit is quadratic, and my equation is y equals, and let's just round everything to the nearest tenth. Well, actually, it doesn't make sense to do that because of some of those values. Let's go to the first digit here. So we have negative 0.008 x squared plus 0.746 x plus 13.472 with an r value. It doesn't give you the r value here, it just gives you the r squared. So we're not going to worry about that. So now I'm going to put that into my y equals. Clear the equation that's already there. If I do negative 0.008 x squared, whoops, plus, what is going on? 0.746x plus 13.472. And then I go to zoom 9. Right there, I have that curve really fits that data nicely and would be better represented of the line of best fit here. So that's all you have to do in order to figure out whether you want to use a linear function or not. And then once you've decided if it's linear or not, you want to make that other scatter plot to then decide whether it should be quadratic or exponential. All right, so let's take a look at another example. So here we have the chart below represents 12 students' high school GPA and their freshman GPA in college the following year. Use your calculator to make a residual plot of the data and again describe whether it's best represented by a linear function or not. So now we're going to have to go back to stat and edit, and we're going to clear our data from before and enter this new data. So for high school GPA, we have 2. You don't have to enter 2.0, 2.2, 3.4, 2.6, 2.7, 2.8, 3.1, 2.9, 3.2, 3.3, 3.6, and 3.8. And for those of you who didn't know, your GPA is calculated between 0 and 4, 4 being a 100. So that 3.8 is a really, really good grade. And of course, I graduated with a 4.0 with my master's. So let's take a look at the next one. So for now, we have FM GPA. So that's their freshman year of college GPA. So we're going to put in 1.6, 2, 3.2, 1.8, 2.8, 2.1, 2, 2.6, 3, and 3.5. Now, if those points didn't line up like I just did, obviously I entered something wrong. So let's just make sure I didn't do what I missed here. 1.6, 2, 3.2, 1.8, 2.8, 2.1, 2, 2.6. Oh, I missed the 2.2. Okay, so now we have all of our data in, they match up, so I didn't miss anything, and we want to go ahead and create our residual plot. So we need to go back to second and stat plot. We need to go into plot 1 and change L2 to resid. Go to second and list, choose choice 7. Go back to your list. Remember, we have to also actually calculate the line of best fit. So we're going to go to Calc, choose choice 4 for Lin Reg, enter all the way through. And here we have our linear function. So we can see we have an R value of 0.8 here. So it's strong, but not super strong. But let's now see what that would look like for our residual plot. So I'm going to go back to Stat, back to Edit, calculate my residuals. So we have to change this to Resid. So second list and change it to Resid 7, enter. Should have the same number of points that we had for our GPAs. And we do. So now we can choose Zoom N9, and there's our residual plot. So here, when we make the residual plot, we see that there are points scattered above and below without a distinct pattern. So if you recall from our lesson earlier, that means that the linear function would be the best type of function to model this data. So our explanation is a linear function is appropriate because there is no pattern in the residual plot. Okay, so we don't really have to do the second point. It says if not, determine what type of function should be used and use your calculator to do that. We know it is linear. We could go back and find that equation. So again, if we go back to Stat, we go over to Calc, we go to choice 4, Lin Reg, enter all the way through. Our equation would be approximately y equals 0.88x minus 0.16. And I could show how that looks with our regular scatter plot by going to second and stat plot, changing my resid back to L2 by pressing second and list and choice 2, enter, and then going back to zoom. And before we do that, I want to put in my y equals. So clearing that equation and putting in 0.88x minus 0.16, then doing zoom 9, zoom 9, there's my line of best fit. And again, like that line of best fit, if I turned it and made it horizontal, it would basically look like my residual plot. The points are scattered above and below. There's no pattern, so there's no curve in the data. Therefore, a linear model is most appropriate. So you're going to try number 3 on your own and then start the exit question and tonight's homework.